traffic intersection uses the lights. So that was how I got the idea. And so you may be wondering how this would help the real world. So
I am wondering
people a lot get hit every day by cars, and we can make safer intersections by higher technology, but we need to like test it out first. Some models are really important. Something like this, obviously, if the scientists are going to do it, they might make something bigger, and they can make things a lot more complicated than this, but that is why models are like important to do it and to test it out. And like for example, they might be able to make an intersection where, like, if someone illegally is walking across, all the lights turn red, so no cars will come by, and that would prevent the person from getting hit by a car. And there's lots of other possibilities that they could do to, like, some cars already have it. It's built in that, like, if they see.
Can I interrupt you just for a second?
They stop it.
Are you saying that there could be some technology where someone crosses the street and they don't have the walking symbol, they have the red, right? And they shouldn't be out there. So technically they're jaywalking, right?
Yes.
But you're saying that we could do something where if there's cars nearby, there's sensors that sense where the cars are, and that maybe all the lights just go red to alert all drivers in the area that there's someone in the intersection who shouldn't be.
Yes.
Something like that.
And we can't, that's not a guarantee that they won't get hit, because there are arrogant drivers out there that will not pay attention to that. But it can, like, reduce the chances. Someone that maybe just, like, glances up, see the light screen, and then just keeps going. They don't actually look to make sure there's actually no one there. If they see that red light, they can stop, and that can save a person's life like that. And there's there's other possibilities that they can do. Like, already some cars stop when there's, like, something there. They can have that built into all cars. And so, but the point is that they can test it out with models. That's why it's important. So that's why models are important in the real world, and making traffic lights, and really anything. If they're going to test it out, it's a new idea, it's a new concept. That's why they're important. And the third subject is about what I learned. So I learned a lot about like how to code using the GPIO pins. It took quite a while, and I also learned about, like, planning it out to make it so that it would that they really would light up, because we had a lot of problems with getting these wires to stay into the breadboard, because initially we had the breadboard actually in the middle of the intersection, and it was too cramped with all of these wires. We didn't have these extra ones because they would reach. So then we tried putting the breadboard outside, and that worked, but some of the wires weren't long enough. So we tried doing some wires, but they wouldn't stay in. And then we got the idea to use separate wires and solder them, and then we got them to stick in. So it took a lot of work. That was the hardest part of the project.
Trial and error.
Yep, trial and error. And so that's another thing that I learned. And I just learned more about, like, circuit building. Because I did quite a bit of it last year, but I just kind of refreshed on that, and I learned.
This is Bennett.
Yeah.
This has kind of been trial and error, because you haven't really had any classes on programming, have you?
No. We did a little bit of, like the snap and hold the block programming, where, like, you drag the blocks and make a code. But this is, like, real, where you actually have to type it. Right now in computer lab, we're learning, like, HTML code to, like, build websites. But we haven't learned, I didn't learn any Python in class before. And, like, an example of the drag and snap code would be if I go into programming and I opened up Scratch. This is what we use in class a lot. So basically you can see this is where I would write it, and I have these blocks. and I can drag them in there, and then when I click on it, I can make that cat move, and I can choose different things. And it can get really complicated, but you don't actually type in this. You have blocks that you can do just about anything. You can make anything on there, but on here, so that would be like we do this in class. So that would be an example of the drag and snap code. And the Raspberry Pi is perfect for this because it's a computer literally designed for coding. I mean, there's a lot of different types of code. If I go into programming, there's different types of JavaScript. There's 2 different types of Python.
Hey, can I interrupt
Scratch.
you for a second?
There's lots of different types of code.
Did you run into some frustrating things?
Yeah, I did. First of all, getting the code to work, figuring out, because from the internet, we were looking at different types of code, but like just using a button or making one light turn on and off, and we would copy it down exactly the way it was, and it would work, it wouldn't work, and we couldn't figure out why, and then we learned that you have to program the terminal to get it to work. And another frustrating thing was that it took quite a while to get these lights to work. We would try a lot of things, and then the wires would pop out. But in the end, we kept working on it, and we were able to get it.
So how did you handle that when it got really frustrating?
Well, just keep going, I guess.
Persevere.
Yeah.
Perseverance.
Something else, huh?
Yeah.
Mm-hmm.
All right, I think we should do a round of applause at this
I
time.
think so.
Woo! Outstanding, Bennett.
Applause.
Great job,
Okay.
guys.
So any more questions?
Bennett, it's so fantastic.
How long would it take me to learn how to do the programming? What do you think?
Well, to learn this, it wouldn't take you too long to learn something like this. I mean, there's lots of different things you can do with Python. I mean, you can, like I said, you can make it draw pictures, and there's lots of different things that you can do with that. You can make it draw more complicated pictures. And then with this, you can also make it do lots of different things with this. It's all a matter of getting it. The basic stuff right here is just telling it when to give the power to the GPIO pins. And then you can hook up whatever component you wanted. In this case, I have lights. But you could hook up a speaker, for example. You need to put in like some kind of an audio chip to it to like tell it what to play. Or you could put in a motor, for example. You could, anything like that. You could any kind of adjustable controller. And also with the Raspberry Pi, it can get more complicated with this. Like, I've heard with Raspberry Pi, I'm not sure which language, it's either Python or maybe something else. You can even hook it up to like control the lights in your house to turn on and off.
Bennett,
cool.
I just got notified by the coordinator of this evening event that we're going to have to wrap it up because we're ready to move on to the dinner. So at this point, let's give Bennett another round of applause. And any additional talk, we can have a call for an additional time for additional talk.
Did Bennett solder the wires at the end?
Yeah.
Yeah, so you soldered them together.
Bennett's very good at soldering. All right, let's hear it. Let's have a round of applause for Bennett.
Good job,
Woo!
Bennett.
Let's hear it for Bennett. Wow,
All right.
outstanding.
Thank you, Bennett.
All right, can you tell Grammy bye and tell her thanks for tuning in, and you'll call her